I'm missing the Tour de France for this. And there are not a lot of people I'd miss the Tour de France for, but Gene is one of them. I first met Gene in the fall of 1984 when I arrived at the University of Pennsylvania to begin my doctoral work, still very wet behind the ears, coming from the Cincinnati College Conservatory of Music, where I studied guitar and some music theory. And Gene, at that point, was in the thick of writing the analysis and cognition of melodic structures, ACBMS, as Lex has pointed out. And ACBMS was having its final gestation and birth as I finished my PhD in 1990, the year it came out. Now, Lex missed one thing. The acronym ACBMS has a striking resemblance, if you leave out the C, to anti-ballistic missile system. And indeed, it is about as complex. It's the only book in music theory and cognition I know that has a helpful glossary at the bottom of every page. All right. And it's complicated. So, because Gene is a deep thinker and knows that things are not always as simple as they seem. So here's what Gene makes of just 3 notes. This is from the first volume, the introductory pages. This is the easy stuff, right? All right. And so then here's, as an example, early on, Gene gives this simplified diagram of what's happening in a Bach theme, what Bach did, with 7 notes. This is scary. Let's face it, ACBMS and the companion volume, which I refer to as SDI, the Strategic Defense Initiative, that's a Reagan era joke, they're 2 of the scariest books of music theory ever published. So you can imagine what it was like in the fall of 1984 as a first-term PhD student, where the first thing I did was walk into a seminar when Gene was teaching this. And so I was immediately thrown into analytic symbology, melodic processes, melodic reversals, cumulative and countercumulative rhythms, parametric scaling. After a couple of weeks, I seriously began to wonder if coming to Penn was a good idea. I mean, I thought I was just going to learn a little music history and study rhythm with Lenny Meyer. Who was this crazy Narmour guy? Right. Well, the answer was and remains one of my best teachers, best colleagues, and good friends. One of the pleasures in preparing this talk was it got me to reread ACBMS, TOMAP, right? We might want to work on that one. And it was something I hadn't done for quite a while. And when I did, I was reminded of Mark Twain's old remark about how, quote, his father was an amazing man. The older I got, the smarter he got. And so too with Gene's book. It's better than I remembered it. And moreover, I realized that it had in many ways influenced my work quite profoundly, indeed in ways I hadn't realized. So Gene, in part, this talk is a bit of an apology for all those times I should have cited your book. Now, as an aside, I will note that Gene doesn't really need my help here. As a former president of the Society for Music Theory, I will publicly acknowledge that within the music theory community, Gene's work is still not as well known as it should be, in part because empirical work is just less well received by some corners of the music theory community, and in part because it's really scary. But on a lark, I happened to look at how many times ACBMS had been cited on Google Scholar. Quite a lot, actually. In fact, ACBMS is cited more times, far more times, than any of the books that have won the Society for Music Theory's Book Publication Award over the last 25 years. It even beats out 2 that have, David Huron's Sweet Anticipation and Fred Lairdall's Tonal Pitch Space. But you guys, Fred, David, you're in 2nd and 3rd place, and way ahead of everybody else. So it really pays to be associated with music cognition. Right. So now I want to talk about some of the profound and sustained influence, or as my title has it, some of the things I've learned from Eugene Narmour. All right, I've already told you that the theory is scary. Gene was scary at first too, but then we learned that he really wasn't that scary. All right. We've come to the outline of the talk. The first thing I will do is give a summary of ACBMS in 10 slides. All right. Then I'll present some aspects of my work, which I'm calling Things I Have Stolen from Narmour. All right. And apply them to the domain of rhythm and meter. And then I'll conclude with some remarks about empirical and humanistic research, of which Gene's work is an exemplar. Okay. The Narmourian intuition. Right. Melodies are alive. Right. Now, Gene's theory is yoked to the musical surface, to each note and its relation to those that precede and follow it. But Gene knows very well that these are not simply locations in some virtual tonal space or tonal pitch space. Tones are alive, or rather they become animated through the act and action of listening, in virtue of the way our perceptual and cognitive systems are disposed to perceive them. All right. And if that's true, if we have to deal with the interaction of our perceptual and cognitive systems, then of course some important aspects of melody are constrained and determined by some fundamental perceptual and cognitive processes. As Gene put it, a few simple laws, perceptual cognitive ones, powerful enough to account for both the multiplicity of singular experiences and for the variation perceived in style, probably regulate the art of melody. Right. But Gene also knows that it's more to it than just these basic constraints from the bottom up. There's also top-down things, what Lenny Meyer would always call nature and nurture. Well, he didn't call it that, but he would always remind us of that. And so there is going to be a necessary interplay between bottom-up and top-down aspects of melodic understanding. And indeed, as Gene points out, if you want to understand how melodies work and how musical styles work, you're going to have to look at those few simple laws that relegate the few simple laws that relegate the art of melody, because what a musician has to do is negotiate between those laws and their particular expressive and architectonic aims. So, what Gene does, as I think we all know, is just ask a few simple questions, the Narmourian questions. Are you a big interval or a small interval? Are you the same kind of interval or are you a different kind of interval? Now, same or different, of course, gets cashed out in terms of both size and direction. Are you big or little? Do you go up or down? Now, you might say that in asking, are you big or little? Are you the same or different? That all that's going on here is that Gene has a firm grasp of the obvious. But of course, what's interesting is that so often scholars don't have a firm grasp of the obvious. We don't see what's right under our noses. But Gene does, and this allows him to ask something that's not so obvious. In light of, are you a big interval or small interval? Are you the same or different? Do you create closure or non-closure? Right? For that's what all those processes, reversals, and things do. Right? And that's it. That's the whole theory. As the rabbis say, all the rest is commentary. But oi, what a commentary. All right. Now, the realization of Narmourian implications is that things get complicated very quickly, very complicated very quickly, and you're not going to get neat and tidy theories, because melodies, even seemingly simple ones, are complex tangles that arise from the manifold ways a few basic pitch configurations can combine and interact both with themselves and with other musical parameters. Right? But that's the basic foundation on which melody works. So, on now to rhythm. and what I stole from Gene. So first I have to confess that I am a Narmourian. Like Monsieur Jourdain, I've been trafficking in Narmourian theory all my professional life for some 30 years, and now only do I realize the implications of that influence. Apologies to Modier. All right. So, just like melodies are alive, rhythms are alive. Events only become rhythms when they hear them with our ears, brains, and bodies, because I've approached rhythm, and especially musical meter, as a kind of entrainment. Well, I won't say more so than pitch, but rhythm perception is bound up with our kinematic sensibilities. As most of you know, that the auditory and sensory motor systems are so deeply intertwined, so you can't but help move when you hear something, if I can find the cursor, like this. One more? No. Okay. That's the stop time introduction to Muddy Waters' Hoochie Coochie Man. It's actually not quite Muddy Waters' Hoochie Coochie Man. It's a loop that I created by muting the soft percussion parts between the stop time da-dum-dum-dum figures, right? Nothing happens on beats 2 and 3 of a 4-beat cycle, but I'm hoping that some of you, even given the early morning hour, were tapping your toes as you listened, even though there's nothing in the auditory signal. And I use this clip as a demonstration of rhythmic entrainment, the way that we as listeners create self-sustaining sensory motor oscillation in response to regular rhythms we hear in the music. And we create these self-sustaining oscillations in response to a wide range of stimuli, all right? So beats and downbeats, our sense of pulse is not out there in the world, in the music, but is within us, an endogenous sensation and perception that emerges through our auditory and kinematic interaction with the rhythms of the external world. Right. So if given one, that rhythm and meter emerge through the listening process, rhythm and meter are subject to a number of fundamental perceptual constraints. And these, if you scour the literature, certain numbers come up again and again, and the picture becomes clear that we get a range of rhythmic activities, about 100 milliseconds or 10 hertz for the shortest, fastest metrical events. We can actually, of course, have shorter events, but they're not heard as rhythmic elements. They're too fast to count. There's a divide at around 250 milliseconds. I'll talk about that in a minute. We have a strong preference for periodicities around 500 to 600 milliseconds, the sweet spot for beat perception. And the slowest beats can get is about 1.5 seconds, 2 seconds, and then the melody will fall apart. So there are these constraints, and they're well known, and indeed they're some of the oldest bits of experimental psychology. Go back to Fechner and Wundt and Stumpf, looking at some of these basic things. So, and of course, given that we have these constraints, there's also learning, and there is an interplay between top-down and bottom-up aspects of rhythmic understanding. So, here are the Londonian questions. Are you a long note or a short note? There are two ways of answering this question. One is to look at relative duration, and this is what music notation gives us, and it's what music theorists worry about and doing rhythmic and metric analyses. But what music theorists tend not to look at is the absolute value of these things. And the absolute value does matter. Indeed, as Paul Fraisse famously made the distinction in mid-century, last century, of the difference between temps long and temps court. And of course, exactly where the divide is varies upon the experimental context in which you study it, but it's roughly around 250 milliseconds. And so we get a distinction between beats and subdivision that seems to be sort of hardwired in. So here is a very banal and familiar example. All right, that's enough. So you know how that goes, and you're tapping your toes and beating. And then when we just speed it up a bit, okay, so the first one is at 88 BPM, and the second one is at 142. And most listeners in the second one tap their toe every other note rather than at every note. And even though we recognize the second one is faster, you're actually tapping slower. Right. And so there's a sense in which the tactus level shifts. So tactus and speed are dissociatable, and that's another interesting story, but I won't get into it today. But we do get this notion of a difference between beats and subdivisions based on the absolute value of the durations or frequency rate of events per second. Now, once again, we have the same question about long versus short, and then when we have successive durations, or inter-onset intervals, are they the same or are they different? Same kind of question from the melodic domain applied in the rhythmic domain. This is actually two questions, because first off, once we figure out are you a long time or a short time on the what side of the 250 millisecond threshold, then within those ranges we ask, are you the same short notes or the same kinds of long notes? Are you the same kinds of beats or different beats, and the same kinds of subdivisions or different subdivisions? And thus we have the difference between isochronous and non-isochronous organizations of meters. So we have Balkan meters where the beats are of different lengths, although the subdivisions are the same. In swing-based meters, you have the beats being the same length, but the subdivisions are different. But in standard meters, we have isochrony on all levels, so the beats are all more or less the same, and the subdivisions are the same. Okay. Then lastly, given, once we've sorted out the long notes and the short notes and the same versus different, does the emergent pattern give rise to a stable sense of meter? Here we diverge a bit from melody, because rather than looking for closure, we're looking for a kind of stable yet open, ongoing temporal cycle. We can look for closure in terms of the rhythmic group structure, but as I'm especially interested in meter, our toe tapping behavior and hearing those cycles of beats and subdivision, that's inherently not closed, but something that just keeps cycling onward. But we want to see the stability conditions for that stable pattern of entrainment. Okay, so the emergent pattern that we listen to can give rise to a stable meter if the periodicities that occur, these beats and subdivisions, occur within a certain range, can't get too fast, can't get too slow, and if their overall consideration is regular enough, and that's, of course, the $10,000 question. And one way to say if something is regular enough is to look and see if the pattern is maximally even, that is to say, as sort of as symmetrically as possible under the circumstances. And in a 4/4 meter, you have 4 beats that are evenly spaced, but if you're in a Balkan meter that's 5, 2 plus 2 plus 2 plus 2 plus 3, you're making that 5 fit as close as possible in a cycle of 11 pulses. So that's, again, as symmetrical as possible under the circumstances, which reminds me of the joke in McLean's a number of years ago to complete the phrase, as Canadian as fill in the blank. And, you know, the entries were things like, as Canadian as hockey, as Canadian as back bacon, as Canadian as But the winning entry was as Canadian as possible under the circumstances. So a good meter is kind of Canadian, you know, it's as symmetrical as possible under the circumstances. We might dub this the Canadian theory of meter, right? Now, so asking short versus long, same versus different, symmetrical, like Gene, I'm focusing most of my attention on the surface. And so it's really an emphasis on these bottom-up properties of musical organization, right? But we know that things get pretty complicated pretty quickly, and in rhythm and meter, the different rules apply on different levels. Eugene originally doesn't emphasize this so much, but I wouldn't be surprised if these are also true in the pitch domain, that you've got different perceptual and kinematic mechanisms for the super short beat level, slower levels. We seem to process these things differently, engage them differently. They might involve different brain substrates. That's not my thing, so I have friends who do that for me. And so when we hear a coherent rhythm, we're actually integrating perception and action on several different time scales into a kind of gestalt. Right. But I mentioned the importance of tempo and absolute value, and that's what I want to share with you a little bit before I finish up here. Did you just give me the 5? Thank you. All right. The importance of this absolute value. A while back I did some experiments with Tommy Himberg and Ian Cross, which we looked at the effect of tempo on the perception of anacrusis, a pickup, which is to say metric accent. And we looked at how different versions of a short, long rhythm change when you manipulate pitch, tempo, implied harmony, and melodic contour. So I won't bother to play these, but we had some melodies that were quite stable. So the first one, which is strongly downbeat oriented, and even if you change the tempo, it doesn't really change much in terms of you hear it starting on the downbeat. And the second one with the ascending skip figure and things like that, it strongly sounds like an upbeat. We've sort of engineered those features into it. Yes, I know there's plenty of clever musical listeners who'll go, wait a minute, I can hear the first one as an upbeat. Yes, I'm sure you can. But that's not a statistically significant result. So then there were other melodies that were anacrustically ambiguous, like this one, right? That start out with a number of repeated notes on the tonic, but then sort of go on, and it's just not clear whether this is a downbeat or an upbeat, but there was an effective tempo. So just notice how the tempos afford different metrical interpretations. So at a slower tempo, and now we just speed it up a bit. And in the experiment, we just said tap every other beat, but wait until you've heard a few notes and then start tapping, and then we could extrapolate back based on where they were tapping as to whether they heard the strong versus the weak beats. And sure enough, when you speed the tempo up, the tap locations for most listeners on most trials would shift. All right. So there we go. It's a nice, very nice instance of a bottom-up effect. But I don't want to forget the top-down bits as well. So for my final example, I'll use a well-known example in ethnomusicology and ethnographic studies, the sub-Saharan bell pattern, which is a syncopated pattern. And here's what it sounds like, and just on the off chance you're not familiar with this. Now, you probably aren't rhythmically engaged with that in some way. The question is how, because this pattern affords multiple ways of engagement. So when I looked at this, and I was very keen on finding these non-isochronous meters, I came up with this. I thought I was so clever. And I really like this diagram, even if it's wrong, showing that in order to minimize the number of syncopations and to sort of see a kind of non-isochronous beat structure that's within that surface, it's 2 plus 2 plus 3 plus 2 plus 3. Dump, dump, da da dump, dump, da dump, dump, da dump, 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 da dump, dump, da da dump. A lovely Balkan interpretation of African music. Well, Kofi Agawu immediately called me on the carpet for that. And there are, of course, isochronous possibilities for this. Uh, so very often the simplest thing is to just hear a rapid 6-beat pulse. There are some syncopations, but it's a very predictable pattern of syncopation since that syncopations persist. But that's kind of fast for beats, and we like beats in a slower range. So I'm betting most of you were tapping your toe like this. And that, in fact, is the way that most Western listeners, non-enculturated listeners, when presented with a bell pattern, will tap it in 3. Right? But of course, enculturated listeners do this. In 4, with only 2 of the notes aligned with the beats, and with syncopations that work differently because you have to deal with triplet syncopations, not duplet syncopations, which is more complicated. It's, in some sense, the hardest way. It would break as the maximum number of GTTM rhythm rules in terms of meter alignment. But in fact, that's the way enculturated listens. Hear the pattern. And what's also interesting is the fact that the pattern itself changes. So again, here is the 3. No, we're not at kludge yet. And then here's the 4. So what's important here is not just that, it has a kind of multi-stability. It's the object itself changes. It's a different pattern when you hear it. It moves differently. And so the interaction between the bottom-up processes and the top-down, I think, is made most viscerally. And now just a couple of concluding remarks, because I know I'm at 0. Kludge is a wonderful term from computer science. As Granholm put it, a kludge, which you know is when you cobble together a program out of pre-existing bits of code, and you're clever because you actually think you can do it that way and thus save yourself the trouble of writing new code. As Granholm put it, it's an ill-assorted collection of poorly matched parts forming a distressing whole. The distressing is the bit. Kludges are distressing. It's not that they work well, it's that they work at all. Perhaps music, or the way we understand it, is a kludge. Meter involves this kludgy perception and action on different timescales, kludgily integrated into a perceptual or kinematic gestalt. And maybe melody is very kludgy as well, because it involves relations amongst elements in different ranges on different parametric styles, and indeed pulls together different parameters into a perceptual or gestural gestalt. And we ourselves are kludgy creatures, the product of a kludgy, since I'm just in love with this word, a kludgy evolutionary process that led to our current physical and mental structure and capabilities, right? It's messy. And Narmour knows this, because he knows that music is a profoundly human endeavor, and so he doesn't gloss over the difficulty and messiness of real music. And so he rejects the notion that a good theory is tidy and economical, right? And simple. And that's why ACBMS is so scary, because of Gene's intellectual honesty and rigor, and he is humble. Let us be clear that music analysis is a paltry attempt to recover the ephemeral, while being heard the transient parts of a musical composition recede in time, precluding ordinary empirical inspection and the capture of unchanging experimental data. Having been heard, the fleeting musical artwork lodges strangely in one's memory as a transcendental unity, defiantly resisting analysis. And that's from the opening pages of ACBMS. Gene's analysis may be many things, including scary, but one thing they are not is paltry. They've inspired a generation of researchers in theory and music psychology, provided a framework in which we can test hypotheses, make corrections, find new problems, and add to the general mess. I've tried to do this myself with a few small ways with respect to rhythm and meter. I hope I've lived up to my teacher's standards. Thank you, Gene.